Hello and welcome to the annual Hawkridge Systems CAD livestream. I'm Scott Woods, Senior Product Manager for our 3D CAD tools here at Hawkridge Systems. And next to me we got...
Hi, my name is Andrew Parkhurst. I'm a Technical Account Manager and I am more of an engineering business consultant, helping customers get the most out of their investments and trying to plan for the future.
Awesome, perfect for this presentation. So today we're going to be talking about the latest CAD tools to eliminate SOLIDWORKS large assembly issues.
Yeah, we know that this is a common request from our customers. I personally work with a lot of customers that let me know, hey, we're having large assembly performance slowdowns, what can we do? So a lot of that experience is what we're going to be sharing from today when we give the best tips and tricks.
Yep, and this is streaming live on YouTube, so if you have any questions, go ahead and pop them in the chat. We'll be monitoring that throughout the session. We're going to have a Q&A at the end, and yeah, we'll answer some of those questions that come up. And if we don't get to everybody, which we probably won't, we will stick around after the end. We'll monitor that chat. We'll try to answer anything that comes in.
Yeah, we're really excited for you guys to join us today. So to give you a little bit of a layout of what to expect is that we are going to have 10 tips. We're going to start off with some global or universal tips, things like opening modes or different things of the evaluation tools. How do you see underneath the hood? Along the way, we really want to take a second or two to give you some extra content. We've been calling this the Nerd Corner content. And this is the fun tidbits that you might not have known of what's going on behind the scenes. Then we're going to give you a little bit more of information on standards of practice, things that you can do to prevent these issues from happening in the future. Maybe you can use them to evaluate and help your current issues. And then we're going to wrap up with some tools that I'm almost positive are going to be new to most of you. We've got some different things that you've never thought of before, or some different tools that are hot off the presses.
Yeah. Of course, this is live, but it's being recorded. It'll be available on YouTube afterwards, and then we're also, if you check out our website, it will be available there probably sometime next week. So stay tuned for that. And once we wrap up today, we actually have a couple really good prizes. Like, they're good. They're pretty awesome. And so stick around till the very end. Don't go anywhere because you don't want to miss out on that.
Yeah, so I'm excited.
Okay, let's do it.
Yeah, let's get into it. Okay, Scott, so where do we start for just how do we introduce this topic?
Yeah, so, as we were getting into researching tips and tricks and best practices for these large assemblies, I think it really became apparent that a lot of the stuff out there really is focused on what do you do after you have a problem. So what do you do with that large assembly?
Yep.
How do you open it faster? How do hardware requirements and all sorts of stuff that is helpful, but what really helps is not having the issue in the first place.
Right.
So we really tried to dive deep on this, dig deep and say, what are the best practices, those 100 little things that you do before you get to the issue that will add up, and your reward at the end is performance.
Yeah, so just a disclaimer, there is no magic wand. There is no easy button. Yeah, we were working with a large assembly. We've got one to share with you today that's really exciting. But we understand that this takes time and money away from your everyday lives. And so what we're going to try and do is be very practical today. We're going to show you exactly what we use. So when I get a customer's model, this is exactly the steps that I use to evaluate and to try and see what we can do to make this work better.
Yeah. Okay, so before we kick it off here, I want to give a shout out to our friend ADI, also known as Dr. Pax. He actually developed this tractor trailer futuristic AI powered combo machinery, and that's a lot of words. And but it's amazing. It's like the perfect assembly for the task at hand. This thing is 6,480 parts. 108 unique sub-assemblies. We got his socials up on the screen there if you want to check him out. He's really into the community and doing training classes, and I mean just overall a champion. He's an awesome SOLIDWORKS engineer.
Yeah, thanks again, ADI, and it was a pleasure looking through your model, and maybe there's some things that you can learn from our presentation, different things to consider for the next one.
Yeah. Alrighty. Well, let's jump into it. So tip one.
Okay, let's do it.
Okay, so I know I said, hey, we're going to dig deep and all these things you can do to prevent that large assembly from getting out of control. but we can't not talk about this, right? So
Right.
this is, so tip number one is use the right opening mode for the task. And really it boils down to when you are opening that large assembly, you have three options for how you're going to open it, how that's going to load into your system. And the same thing goes for your drawings as well. And so, you can load it fully resolved, which loads every single thing. You can do whatever you need to do. Lightweight mode is going to load that geometry, but it's not going to load the feature history. And then we have detailing mode in drawings, or large design review at the assembly mode. That's just going to load the graphical data. And if you look on the screen here, it takes about 10 minutes to load this assembly. It's a large assembly.
Yeah. So what you want to think of is that there are three elements to every SOLIDWORKS model. So you have the features information, you actually have the bodies information, and then you have the graphics. When we're talking about some of the quicker methods like design review, that is going to be specifically the graphics that you're going to see. It's kind of like your eDrawings viewer. Same thing with detailing mode, which we'll talk about a little bit more in a moment, but this is going to open up rapidly. Something that you can realize is that this could be your default setting for how to open up large drawings, but also making sure you choose it on your opening dialogues. And then when it opens, you can actually get a lot of functionality out of that large assembly through large design review, but then you could actually go from there to lightweight or to resolved.
Yeah, there's also a system option, if you saw there in the video, where you can set SOLIDWORKS to, if the assembly is over a certain threshold, like 500 parts, have that automatically open in a certain method.
Yeah, so that's going to be your large assembly methods. So what it's going to do is it's going to default to lightweight mode. A lot of people have seen the feather on the icons for their assembly tree, and lightweight means that it's only the bodies and the graphics and not the features. Unless you expand it, the feather goes away. That's going to be loaded into your current memory. The thing that you have to understand is that the lightweight mode is very good for the individual features and the components, but it is not affecting the mates or the different assembly level features. So a lightweight mode is a very good start. It's where most people are going to live day in and day out. And you can usually right click on the design tree itself and either ask for it to set from lightweight to resolved when you need all the functionality. One of the things that we're going to show is assembly visualization. It needs to be fully resolved in order to get the information that you need.
Yeah, so I mean, you can load the whole thing lightweight and then choose which ones you want to resolve at that time, or just resolve the whole thing.
Right. And so what we strongly recommend is that if you've never messed with the other opening methods, if you always just default to lightweight, maybe consider opening in one of the faster methods and then allowing that to be the entryway to start the model, load your graphics data, whether it's detailing mode or large design review, and then opening up your lightweight from there.
Yep. You see that in large design review, it took under a minute.
Right.
From over 10 minutes. And then at the detail mode for the drawings, it's like 5 seconds. It's right away.
Also remember that on that opening mode, you can start to look at the configurations. If you're in the sheets or the drawing, you can load specific sheets and not load the other information. So remember that that opening mode is not something that you just breeze by. You can actually get a lot of functionality out of just kind of looking at the options that it gives you.
Awesome.
Yeah?
Tip 2.
All right.
Okay, let's do it. Okay, so we got one more that's kind of what do you do when you have a problem and try to analyze it.
Yeah, this is the universal tool. This is my bread and butter. I use it every single time I interact with a customer's model.
And really, it's to me, it's the foundation of this whole presentation.
Right.
And the tip is let SOLIDWORKS tell you what's wrong. And so there's two tools for this. There's performance evaluation and assembly visualization.
Right.
And so the performance evaluation, you can really dive in there and say, well, what component is giving me these problems?
Yep.
And then the assembly visualization dives a little deeper, more in a visual method.
Right. So what you see on the screen is the performance evaluation dialog. So starting from the top, I always work from the top down. It's going to talk about opening modes. It's going to talk about the version. So SOLIDWORKS highly recommends for best performance that you update all components to the latest version. Same with graphics triangles, so that's going to be your tessellation data. So how hard does it take to actually show what's on the screen? And then it goes all the way down to components, mates, and all the different levels.
Yeah, and I'm guilty of making this mistake, right? If you open this large assembly, I did it with this one, and dive in and be like, well, what's wrong? And they spend a lot of time trying to figure it out. just let SOLIDWORKS tell you what's going on. And in this case here, you see that this chain, has a lot of triangles. And we've got to figure out, well, why is that?
Right. So assembly visualization is a little bit more of a surgical tool. I'm going to open this up and I'm going to look for 3 main categories, and that's going to be graphics triangles, it's going to be opening time, and it's going to be rebuild time. Now, opening time is going to be the one that you're probably the most aware of and worried about, and that's going to be the file size, its location, all the different things that it needs to load into memory for the different bodies data and all those kind of different things. Now, rebuild time shouldn't be too bad as long as you're opening up in lightweight mode. But it does play a part when you start to do fully resolved, and if you have to go into assemblies, components, all of the different levels that are available.
Yeah, like you saw that chain there.
Right.
Had ADI's logo stamped right in.
Right.
I mean, maybe that's necessary for rendering or something, but yeah, it really is. You'll see the theme of this whole presentation is, if you have some details that maybe don't need to be there at the top level, then don't have them there.
Yeah, so our recommendation, if you haven't gotten used to opening up the performance evaluation tool, work from the top down and start to really recognize that everything matters. Everything adds up from all the different components, where they're located, all the different mates. So this is the place that we actually evaluate how many mates there are in the top level assembly. And also how many components. Everything adds up. Same thing that we were just looking at it. This actually performance evaluation tool is not just for assemblies. You can use it at the part level. If you have a lagging part, you can see actually all the features and which one has the greatest pull on the resources. And for your drawings, it could show you the sheets and all the different things that add up. So performance evaluation is your go-to stop. First thing I do when I open up a model that I'm not familiar with, I will go and look at it, and I will open it up the individual files and subassemblies directly from that tool. Assembly visualization, that's the one where you're playing with the cool pictures and you're trying to understand a little bit of where our efforts are going to be paying off the most. So we're going to show you a little bit about image quality or graphics triangles and how you can start to improve the performance.
Yeah. All right, so now that we have like these 2 big
These
hitters,
are the basics.
Yeah.
Everyone should be aware of this one.
Yeah, I mean,
okay.
They're the basics, but also like the most important in a way, right? So now let's take a step back, go under the hood a little bit, and start talking about how we get there.
Okay.
Okay, so this tip is use the right mates. And you'll see with a lot of these titles, like that can go deep. Like, what does that mean? Well, it could be, hey, use the right mate for the job, or even use the right mates in the right sequence at the right time. So for something like a chain mate. Chain mates are awesome if you need to make an animation, right? And you need to render that animation, you want it to function correctly, but it's going to be heavy. And if that's at your top level assembly that you're going to be using for a drawing, like do you really need that mate?
Yeah, so our basic recommendation is to keep it simple. That's the same thing that engineers have been saying for a very long time. It's use your basic mates, but use them in a way that's constructive to the design and doesn't really get fancy unless you really need it. There are the mechanical mates. Those are getting into kind of a deeper level of functionality, but a planar mate, coincident, concentric, all of these things are the bread and butter of how you should be mating. Now, there are 6 degrees of freedom for any component. What we're going to see on the screen is that you can actually use a little known tool called multi-mate inside of the mate tool. And this is more of the hub and spoke kind of concept of how you would actually start with one main base and mate everything to that as a reference. You can use multi-mate to add the same mate to multiple items at the same time, or you can just use the concept when you're mating. I'm going to start with one key portion, and then I'm going to build on it from there.
Yeah, and so I mean, that's a great point. Like, if you don't need multiple mates to do the job, you get it done with a single mate, it cleans up the feature tree, makes things a bit faster. Right.
Remember that all mates are non-linear, solved inside of the assembly.
All at the same time.
All at the same time. So it's matrices. I learned matrices in Algebra 2 back in the day. I hated them. You don't actually have to do them when you're using SOLIDWORKS. It does it in the background for you. But it's solving for unknown variables. So it has to locate it in space. It has to make sure that the other ones are solving. When you have errors, That's when you have two mates that are conflicting each other. And errors are actually the place to lose performance the most. If you open up a model and it has the ketchup and mustard on it, the yellow warnings and the red errors, that's the first thing that you want to actually take care of, because that's where your performance is getting drained every single time. It's kind of like a room with 10 locked doors, and SolidWorks is actually going to each door and trying to open it, and then it fails, and then the next time it gets a chance, it's going to try again to open up the 10 locked doors.
All right, so would you say you're a big fan of
Yeah.
flexible subassemblies then?
So if we're going to talk about mates, this is a personal pet peeve, but the key thing that customers need to realize is that subassemblies are your friends. This is a key aspect of reducing the number of top-level mates. You actually want to have about 50 on your biggest GA level. You want to have the least amount of mates as possible. And we're going to show you some other tools that allow you to reduce those top-level mates. But when you reduce them in a subassembly, there is something I see ubiquitously out in customers' models, and that's flexible subassemblies. Do you want to tell them what a flexible subassembly is?
Yeah, so it's you have all your mates and everything at the subassembly level, and in that subassembly, man, they work great, right? But then you bring that to the top level assembly, and you can set it to flexible, so all of those mates are functional, right? But then you have potentially double, tripling your amount of mates in that top level.
Yeah, so all the good that you brought from subassemblies is now wasted because it's now at the top level, and they count towards the degrees of freedom. So you get motion out of it to maybe test and make sure that things are functionally correct, but then you have all the performance hits. So what you want to do is you want to use flexible subassemblies judiciously. You want to use it temporarily, use it, turn it on, check it, turn it off. Do not mate to items that are going to be turned on to flexible subassemblies.
Alrighty.
All right, so I've ranted enough about mates.
Great stuff.
Let's do tip number 4.
Okay, so tip number 4, and this is usually where I go ranting on too long.
This is your turn.
So this one's really hard to show with video and stuff, so I will try to explain it here. But there's a method, and this is tip number 4, called the master sketch method. And if you think about how this functions, and there's a couple ways to use it. So you could have like a part within a top level assembly, and that part has a sketch in it. And it can be actually a really complicated sketch that's driving a bunch of sketches downstream. You can also use it even in a part level and have that original sketch driving a bunch of features, a bunch of different sketches within that same part. If anybody here attended our session, actually 1 year ago, for the surfacing tips that we presented, I actually did that in that model. It was a Stormtrooper helmet. I had a master sketch, and it was driving nearly that entire design. And it worked really well, and it saves you a lot of time when used correctly.
Right.
However, I was trying to create an infographic of this to show like how to not use it correctly. And the thing I love about SolidWorks, it allows you to create references everywhere. You can have sketch references to other sketches, to parts, from parts to sketches, from parts, like extrude that up to like a vertice that's in an assembly. That it gets crazy. So I found this GIF. I think this not GIF, but image here. I think this explains it best. I think it's from
Charlie Day.
Rim, where I was creating this infograph, and it just went crazy, and I'm like, here you go. It kind of gets the point across.
So let's talk about top-down design methodology. Okay, so a master sketch method could be a beneficial use of a sketch to generate the overall design. So you could actually have multiple components being driven by one resource. This one resource is going to have kind of a relationship. You are setting up a reference that will be a talking reference, and we're going to talk about that next in terms of how you want to have that limited. But what you could do is you could reduce the number of mates. You could actually have this do multiple components inside of the same assembly. You can have a lot of different things being driven by this master sketch method. You just want to recognize that this is creating an external reference. So whenever we talk about this, all day today, we're going to be using the Goldilocks method. And that's just the right amount. Not too much, not too little, just right.
Yep. With with great power comes great responsibility.
Yeah, so
Right.
a lot of users might be familiar with master sketches from other CAD packages. SolidWorks is something that you can do this, but you might not have ever even known that you could do this. We would love to show you a little bit more if you have questions about this. It's essential for some users and customers a part of different industries. I've seen it a lot with customers and they bring it to me. What I always encourage though, again, is that Goldilocks principle is that
Yes.
a little bit goes a long way with this tool.
Yep, absolutely. Okay.
All right, next tip is my favorite.
Okay, cool. So, and this, right, just kind of follows that same methodology of like, let's control, and the tip is tip number 5, and it's control external references. We talked a little bit about this, but it is along the same lines of like, hey, it's great that we can connect externally to like imported files. Maybe you have a step file, and when that step file updates, you want it to update in SolidWorks. Like SolidWorks allows all of this, but you have to control when it's necessary and when it's just lagging you down for no reason.
One of the examples that you're seeing on the screen is a component inside of an assembly. Now, there are sketches inside of that component and other sketches, and what's happened is that they've actually been linked with an external reference. You can pull up those external references by right-clicking on your design tree and show me external references. There are 2 tools or 2 options that you have to be aware of: lock and break. Lock is going to actually stop the resolving of that same external reference over and over again, but it still is part of the file, so it still has to talk. But the break breaks the connection between those 2 parts. And that's where it's a little bit dangerous, because you set up the external reference on purpose, but now you're actually cutting them off. What we highly recommend is that if you're doing top-down design, you want to use this appropriately and then disconnect it when it's the right time.
And I think a great example of that is like you bring in a CATIA file into SolidWorks, and if anybody
or any
any imported file.
Yeah, so step files, IGES files, anything will come in through 3DX or 3D Interconnect.
3D Interconnect, yeah, that's the tool that's making that connection.
Right.
And I see this all the time with, and that's why I reference CATIA files, because I see that quite often, where you can bring that in to SolidWorks. And by the way, with SolidWorks, you can actually bring that in on every version as long as you're on support. And that was new a couple years back. But it creates an external reference to that file, which is fantastic. So when you're in CATIA or you received a part in CATIA and you go and replace that one, it's going to replace it in SolidWorks. You got to remember it is an external reference and it's having to process that.
Yeah.
So do you need that or not?
Usually you want to use it appropriately. So start with the reference, break it when it's appropriate to break. The other thing that we saw even earlier today is that you can insert parts into parts. This is something that you probably didn't know is available, but it's good especially for design library components that are blocks that you want to add to a part design. But remember that that is actually creating that kind of external reference. The things to watch out for on your sketches are these little arrows that you saw in the video. And an arrow next to a feature means that there's an external reference. And if there is an asterisk, that means that it's locked. If there's an X, that means it's broken. And if there's a question mark, then that means that the reference is out of date and needs to be updated. Yeah.
So as you probably see a continuing theme here, right? Where it's like, just do enough of what you need.
Right.
Right.
Yeah. And it's do enough for what you need and then break it or resolve it later. Don't always have everything at your fingertips. Some customers that I've worked with, they're like, oh, we need those external references. I'm like, when do you need them?
Yeah.
When we're designing it. I'm like, okay, so when it's designed, do you still need those references? They say, yeah. I was like, why? And they're like, I don't know.
Because it's part of the web.
Yes, because if we break it, it'll be broken forever.
Yeah, right. And it's like, yeah, I mean, and I love this about SolidWorks, that it allows you to make all these connections, and it's associative, it's parametric, and that is what makes SolidWorks great and fantastic. However, like we said at the beginning, there's 100 little things you can do, and each one of these little references is just a tiny little bit, but with a huge, huge assembly, it has to load all of those.
Yeah, it's basically a spider web that it's constantly having to communicate and make sure that it's up to date.
Absolutely.
So watch out for that.
Okay, tip number 6.
Yeah, let's do it.
Okay, so this one is tip number 6 is make a simple configuration. And just like I kind of said earlier with the titles of these tips, that can mean a lot of things.
Right.
Like in SOLIDWORKS, the terminology configuration is like, hey, I'm making a configuration of this part or this assembly.
Right.
But it could mean a multiple.
Because it works differently in 3DX, right?
It totally does, yeah. And so, and we'll talk about that a little bit when we get into like data management systems. But yeah, so you see if like, you know, this assembly took 10 minutes to load, but I created a configuration of it, a simplified configuration, suppressed the components that I don't want SOLIDWORKS to load at that initial load, and I'm able to load it fully resolved in 33 seconds.
Yeah.
So you load what you need. Again, like everything else, the Goldilocks zone, when do you use this and when is it not a good idea?
Okay, so some things to look out for is that you're going to want to have just the right amount of configurations. If you start to use this for your business, we're going to talk about that a little bit later. You might want to watch out for it depending upon what your data management philosophy is. We recommend that you just have one configuration for parts, assemblies, sub-assemblies, and top-level assemblies, and that might be the simplified configuration. For an assembly, something to think about is internal geometry. Things that are inside of the model. You can actually use selection filters to select things based upon size, maybe whether or not they're internal components. If you start to select things that honestly you can't even see from the user's point of view, what difference does it make? Do you really need to load that into the memory, into everything that's going on? You can actually just reduce the graphics load by hiding them, but they're still there. The SOLIDWORKS knows that they're there. The bodies are still there. You just can't see them anymore. So you have to watch out for that. So with configurations, shoot for one, the simplified configuration. You can actually open up the simplified configuration during the opening dialog. You can choose which configuration and you can automatically go to that one, even if it wasn't the last one that was saved.
Yeah.
Another thing to watch out for is display states. So this is going to be a kind of a partnership with configurations, and that's going to be something where a display state is just graphical information. It's very low in terms of what is the burden of the file size, the opening time, rebuild time. Configuration adds everything. It adds to the file size. Have you ever just done that where you just added one configuration and saw what happened to the file size?
Oh yeah.
It's super fun. Yeah, you're going to be shocked and amazed that because it basically has copies of the same file.
I saw a screw that was like 1.5 gigs. No joke.
Oh, wow.
Yeah.
Just from all the different configurations.
Yes. Yeah.
Yes. That's something that you have to watch out for. So again, the Goldilocks principle, just have the right number of configurations. Start with a simplified one, maybe a couple of functional configurations, but really limit those because they can hinder your file quite a bit.
And going back to display states, like, you know, I was first introduced to display states. I saw that as, oh, a way to change the color. So we're going to display that kind of like configurations, but in just different colors. But it can do so much more than that.
Right. Okay, so simplified configurations. The next tip is similar but different.
Okay, so tip number 7, and I think this is my most favorite.
Okay.
I do. So this is use appropriate part detail.
Yeah.
And this is something that I think we're all guilty of at some point. I know I definitely have been, where it's like, you know, I want to design this thing exactly how it's going to be manufactured.
Right.
And ADI, if you're listening, like we totally get it, but dude, like way over engineered for this one. Maybe
us.
for us, exactly. This component that we, you know, pulled up with the assembly visualization has nearly 700,000 triangles. It's a beast for this little component, and you know, simplifying, we got it down to 8,000, which is huge.
Yeah, so this is a starter coil, and what you always have to watch out for are curved surfaces. So a lot of people know your threads, your helical, you know, different things, small fillets, embossed text. When you look at the graphics triangles that are being generated by just these features alone, this is where you start to get into the hundreds of thousands, millions of graphics triangles. And you always want to watch out for that. So you want to, whenever you have a vendor component that you're pulling off McMaster car, you want to look and see if you can suppress anything that's not necessary for the functionality. And then you also want to turn down the image quality. So we were talking about that with graphics triangles, but inside of your system options on the document properties specifically, there is the image quality slider, and you want to make sure that's far off to the left. Don't have it anywhere near the red. It's not helping you at all.
I really like how you called out that that is a document property.
Right.
And I don't think a lot of people understand that because most softwares, right, you have a application property.
Right.
You like turn down the quality so that it loads faster, right? Well, this is the actual document property. It lives inside that part, so it's reducing the size of that part, increasing the performance of where that part is used, and that lives with that component as you move it from assembly to assembly.
Yeah, so something that you can do to give yourself a bunch of help for your entire organization is actually clean up vendor components as soon as they come in. So if you turn down the image quality slider, that will actually propagate, and for every time somebody opens it up from then on, they'll actually have that more optimized model to work with. So this is similar to our last topic. So you could do it with a simplified configuration, but there are times, like we've worked with vendor components for some of my customers, and they're never going to need the full detail because they're not the manufacturers. They're ordering it, and they just need the space claim and surfaces for mates. So instead of creating a simplified configuration, there's a lot of opportunities where you're just going to simplify it once so that it's done.
So let's say that that the model has to be 100% accurate at some point.
Right.
Using that slider is a good way to like leave the detail in there, like slide it down. We could suppress it. We get into stuff like configurations we talked about previous. Like that could be detrimental at some point of like once you get into like a PDM system, which you mentioned with 3D Experience.
Yeah.
Whereas in 3D Experience data management, you if you have a bunch of configurations, you upload that to your data management, it's going to split those off in what's called physical products, which is basically different assemblies for each.
Yeah.
And it's like, okay, now how do we control those? Do we want to rev control each one? Or do they follow the same scheme? Like, there are questions to be answered at that point. So simplifying your part and doing it this method with that slider, it's just a really, really easy way to save a lot of performance without any of those like, ooh, now I have to think about that.
There are some manual methods of reducing the geometry, whether you saw Scott work directly with a SolidWorks model that just needed to be suppressed, different components. If you're working with more of an IGES step file, universal file type, you might actually want to look into maybe using a defeature tool or just using kind of like merging extrusions to try and reduce either internal geometry that's not necessary for your model, or to just have it be a simplified form, a space claim. I've seen a lot of stepper motors, I've seen a lot of motors, pumps, a lot of things that come directly from the vendor, and they're making models for their use. They want it to look good. You just need it to actually fit and be on a bill of materials.
Exactly.
Yeah.
Okay.
All right, so those two are pairs, and then the last one's kind of a different one.
So we got three more, but what do we mean by the last one is this is the last specifically for SolidWorks.
Yes.
So and again, like I love this one. And it's not technically a large assembly tip, but it absolutely is a large assembly tip.
Yeah.
And the tip is drawing workflow matters. And in your drawings, those are where your assemblies go. Those are where your parts go. It can reference multiple assemblies, sub-assemblies, and typically this is where everything rolls up to. Right? So the reason why we named this drawing workflow matters is because not only how you open it, but the way that you actually create the drawing really matters.
Yeah, so in the opening dialog, you're going to want to look for detailing mode. You can also select which sheet you want to load, and maybe there's some sheets that you don't want to load. Drawings can actually be longer and have worse performance than assemblies do.
Absolutely.
So if you only need to go into one specific sheet and do your work, do that. And then for all the fully resolved, you're always going to be placing your views. You can do auto dimensioning, auto ballooning, maybe create your bill of materials tables. But then we're actually going to recommend that once you have your drawing set up, you save it and then close out of it and open it back up with detailing mode.
Yep. And by detailing mode, I love the name of that because that is exactly how it sounds. This is where you do your detail. And so, you can set up your whole drawing exactly how you want it with your sheets and your views and your cutaway views and everything. And then you were talking about manually adding like balloons and stuff. The auto ballooning that does require to be resolved.
Right.
But you can have it resolved, auto balloon it, auto dimension it, and then save, reopen, save, close, reopen in detail mode, and then you can move those around. You can delete them. You can add additional ones. Like you can do a ton of stuff in this detailing mode, and I think a lot of people don't understand that. They're like, oh, the detailing mode is just for viewing it. It's
Right.
just for a quick, like almost like a PDF. And it's not the case. You can do so much at that level. And if you're not doing it, you're wasting a lot of time of, that you probably could be.
So this concept isn't fully new. There was a concept called detached drawings.
Yes.
And this allows you to open up a SolidWorks drawing without the actual reference components, your assemblies and parts. This means that the graphical data is stored in the drawings file. That graphical data is the power. So you can actually add those manual dimensions between different points. You can add those manual balloons. That's why we want you to start with detailing mode. And you can actually set that as your default. If you don't work with large drawings all the time, it might be a little annoying if it's opening up every single time with detailing mode. But you could set it as your default and it will open up the drawing as fast as possible, kind of like your large design review. Then you have the option to actually fully resolve the drawing or go to lightweight mode, similar to how you can do that with your assemblies.
Yep. Yeah, that's a good catch there, right? Just make sure that it is resolved if you need to load new data.
Right.
If you need to reference anything that is actually in those components.
So the thing to watch out for with drawings is that size matters. So the number of sheets, the number of views, and then the specialized views. So the ones that actually cause the most burden are going to be your section views, your cutaways, anything where you're actually having the system do the calculation, because it's referencing the SolidWorks model, and then it has to show on the screen a 2D representation of what it found. And it's really fun because SolidWorks actually knows what to show you and what not to show you, especially with internal geometry. Like it's doing a calculation that says, I know that those gears are internal to that tractor, but the user can't see them. So I know they're there and I'm going to calculate that they're there, but then I'm not going to show them.
I love watching Andrew here nerd out.
Yes.
It's great. We get at a certain topic, and by the way, like this is not scripted. Like this is just us nerding out. So you brought up a couple of really good points there of like, in a drawing, things exist that don't actually exist in 3D.
Right.
And so you're like, I'm gonna cut it at this certain angle, and all of a sudden the software has to be like, oh shoot, I gotta like have it like relative to that face, and I have to, and then what lines do I show? What lines do I hide? Are lines all cut off or some displayed, like halfway? And if you think about like what the software is doing, it's super, super impressive. It really is. And it's really easy to get frustrated, be like, that didn't quite work the way I wanted it to. But it's like, if you think about what it's doing, I mean, it's taking all that geometry, and it could be a really, large assembly, and you're cutting it at a certain angle, and it's got to display that. And is there hatching or anything going on? Like, it all has to be processed.
So the tools that we've just given you, the last 4 or 5 especially, kind of add together. When you get to the drawing phase, you should be using some sort of simplified configuration or display state. You should actually have appropriate detail. Like we said, if you have internal geometry that's not even visible for the drawing, you're actually making SolidWorks think about it and then decide that it's not visible and not showing you. But it takes the same amount of performance to do so. So if you can actually use those tips combined, so simplifying, and especially at the GA level. So when you have a general arrangement drawing, I've seen plant layouts where all of a sudden I'm in the assembly and I will zoom all the way in and I can read the embossed text on the actual nameplate of a vendor component. And I will ask them, I'm like, do you need this at the GA level? And they will say sheepishly, no. And I was like, well, then don't have it there. Okay, so that's what we were trying to encourage, is that when you get to a drawing, if you're at some very large overview drawing, are you working with an appropriate model with the reduced complexity, reduced detail?
Great segue into the next tip here. So,
right, but if you do need the power, if you need all of that detail, if you need everything at your fingertips, what should they do?
Yep, okay, so let's get into that. So tip number 9, taking a little step to the side here. And again, like this tip isn't for everybody, but it is for that whole plant layout. And I need to have the data there, and it needs to be geometry. What in the world do? I pushed everything to the limit. I don't know what to do next. And this is using CATIA for large assembly assist. So CATIA is a completely separate CAD tool.
Right.
It is designed specifically for really, really, really large designs. And I made this super silly assembly here just to represent that. because this tractor trailer, loading it in SolidWorks, it chugged, right?
Right. It was tough.
I mean, with all the geometry and everything, of course, this doesn't have feature history,
Okay.
right?
Yeah.
But it is usable geometry, and I can in CATIA, I could add additional components, I could import stuff, I could create new content. Like, it is an assembly that is fully functional, dimensioning everything.
Right.
And I, multiplied that tractor 4 times, and I added this other Resmin demo file set that we had. It was about an equal amount of components, and I can't break the thing. You rotate it around, zoom in. It's super, like, the performance is there.
So CATIA is part of the Dassault family. So a lot of SolidWorks users maybe not have any experience with CATIA, but this is a premier, robust tool for very high-level design. Actually, it lives on the 3D Experience platform. The Bridge is the 3DX platform that SolidWorks natively works with as well. The file types are actually different. You actually have something called a kernel. SolidWorks is based upon the Parasolid kernel, and then CATIA has its own
CATIA kernel,
yeah, CATIA kernel. I think it's a CGM, whatever it was. They have been different for years, and so there was a little bit of a gap between them, but now that gap's been bridged, and you can actually mix the design methodologies to utilize SolidWorks for what it's really good for and CATIA for what it's really good for.
Yeah, and then there's a third option.
Okay, yeah.
We don't want to get too complicated here, but there's a third option called XDesign.
Right.
XDesign is sort of like SolidWorks, and it's sort of like CATIA. It runs completely in a browser, so it has no install needed, and it is there as a great tool really to bridge that gap.
Right.
And so you're talking about kernels, like what is the platform at the very, like, the foundation of the software, and why does it behave the way it does? XDesign actually runs off the CGM, the CATIA kernel.
Gotcha.
Whereas, but it is completely designed for the SolidWorks user.
Right, it looks and feels
Yes.
familiar to someone who knows SolidWorks really well.
It does. The icons are the same. They're named the same. They might be located at slightly different locations.
Right.
But I mean, if you want to, like, model the way that you model in SolidWorks, you pick XDesign. It's really easy.
Yeah. This tool lives on 3D Experience platform. So this is something where a lot of the data that we're talking about, so sometimes we're talking about data that lives on 3D Experience. We were talking a little bit before about PDM and what happens with your data with that. It happens to kind of correspond to how your company structure is set up. So we were talking about configurations. If your company is currently utilizing configurations, you might want to reconsider why. Because when you have any sort of data management, it forces you into questions about what the revision scheme is, how are you going to work with updates for different configurations, why are you grouping these things together? There are a lot of benefits, but can you get those from other ways of grouping inside of a company?
Yeah, and so, again, this tip isn't for everybody.
Right.
But it is like, hey, I have maxed out my hardware. I have tried every large assembly tip there's possible. I'm using all the best practices, but I have to design this entire nuclear facility with every cable and pipe and everything. And how in the world do I show this all at once without splitting it up into groups? And CATIA can bridge that gap.
So we've seen CATIA examples for very complex part design. So if you had like nonlinear geometry, waves, I think it was a water treatment plant that I saw that at.
Yep.
And then you can also see it as something of like the end designer's tool for assembling all the different work that's been done by all the different designers. So we've seen that with electric motorcycles, anything that has that kind of complex design. CATIA is that robust top-level tool for that use.
Bringing 5,000 engineers on a single project that is multi-gigs of data, right?
Yeah, so it doesn't mean your whole company actually has to transition to CATIA. We still love SolidWorks. We're just saying that if you are hitting the edges and you're doing everything that we're recommending, there might be only like one other pathway, and that's to get beyond the SolidWorks capabilities.
Yeah, I just want to reiterate that this is not saying stop using SolidWorks, use CATIA. This is to use CATIA to augment SolidWorks, to take your designs that you've been working on and continue to work on in SolidWorks and bring those into CATIA for that assembly performance. But then, like, hey, I got to make a drawing of this.
Right.
And so you're going to take the whole plant layout and maybe make a drawing of it.
It's a big step for a company, but if you're somebody that is interested in that, we can help.
Absolutely. Hit us up. If you fall into the category of like, maybe this is where we need to go, let us know.
Yeah. Okay, last one.
Okay, tip number 10. So do you think...
This one's a little known topic.
Yeah.
I don't think people even know what this is, right?
Yeah, but I think it's probably the most asked about.
Yes, very much so.
So it's like everybody's like, where is my AI? Where is it? So this tip is virtual AI assistants. Assistances. So these are the AI companions for all of the DS products,
right?
Where it's being worked in. So right now everything is in beta. You can kind of see the release up there on the screen of like when we were expecting, different.
There are tools that are released now, right?
Yes, there are.
But then there's a lot more coming.
Correct. And all of them that are released now are technically still in beta.
Okay, so they're not fully fledged, like robust, ready to go completely.
Mm-hmm.
Okay.
Yeah, so it's really like you can get some use out of it today, and you're going to get a whole lot more in the future. This isn't something that is passing. This is the way this is where all the R&D is going. This is the future of design.
Right.
And we have 2 AI
companions, right?
We got more on the way, but today we have Aura and Leo.
Okay.
Aura is your AI companion for the SOLIDWORKS help files. She knows everything about it. And then there's what are called the SOLIDWORKS
forums.
Yeah, the user communities.
Yeah.
And these are communities that you have from professional SOLIDWORKS users. You have the developers in there. You have folks from DS and SOLIDWORKS, and you have it's the source data. That's where it gets its power from.
So it's a large language model that only sources from verified sources.
Exactly. It's not going to pull from Reddit and Google and Yahoo News and you know what I mean. Some of these other tools, it's great. You get everything, and you can kind of filter out what you don't want. But when it comes to design and SOLIDWORKS, we just want to give you accurate data.
Yeah. So that's Aura.
Yeah. So Aura is like great for saying, hey, I want to do this thing. What feature would you recommend?
Use this feature, use this tool set.
And they'll be like, oh, use the fillet. Okay, where do I find that? And you know what I mean, and able to guide you. And then Leo, I'm most excited about Leo. So Leo is your engineer, is your intern, right? That's going to work 24 hours a day without any sleep. But Leo is for design.
Okay.
And right now we have a couple features it can do, and it's going to be able to do a ton more in the future. Like, hey, I need a bridge that needs to span this certain distance, need a certain load, have a certain load. Can you help me design it? And actually, it will walk you through the design.
So this is interacting directly in the design space of SOLIDWORKS.
Yes.
Okay, gotcha.
Yeah, and so if you want to make a drawing, be like, hey, help me make a drawing of this. And it'll say, well, what do you want the format to be? What do you want the page size? What do you want the engineering standards? Is this ISO? What it will ask you these questions if you don't feed it that information. You can go ahead and talk to it. You can say, hey, use this template, use this standard. In the future, we're going to be able to do things like, hey, this is another drawing I'm trying to mimic. These have my drawing standards on it. Can we use that? And it's learning, right? It is a beta software. I had the privilege of taking a peek under the hood a little bit a couple weeks back with the R&D team, and there is stuff coming out that's going to blow your mind, and I'm really excited for that to become a reality.
So Leo, the thing that I'm excited about is that I've been working with customers with large assembly performance issues for many years now, and Leo is going to be a great tool to be able to look and apply some of these best practices that we've been talking about to your large assemblies. It's not ready to do that right this second, but be very on the lookout that that's what it's going to be great for, and it's going to come down the pike very, very, very soon.
Yeah, great connection back to our topic here, because like I said, AI, this is the future. Like, it is in development for things like, hey, can you help me with this assembly? I need to figure out what's going on, and it's going to be able to walk you through it. So stay tuned. These amazing stuff is on the way, and if you want, check it out today and see where it's at. Okay. Well,
we're looking at the chat here and just trying to catch up. People have been talking about the model and the car.
Nice.
Somebody had a really great question about understanding SOLIDWORKS has all these functions and features, but the advice is for better performance not to use all the features that SOLIDWORKS can do.
Goldilocks zone.
What would you say to that?
Yeah, I think this is a Goldilocks zone. Like, and that's what I'm saying. Like, I love this about SOLIDWORks, and this is pretty unique to SOLIDWORks.
Right.
I use many other tools, and
CATIA works totally differently.
totally different.
Right.
CATIA is like, hey, you're going to design it, and you're going to design it with these tools this way. SOLIDWORks is like, how do you want to design it? Here's a bunch of tools that you in a tool bag, and choose the one you want. And with smaller designs and with smaller drawings and everything, you can use them all and use them as many as you want, and it's going to be fine. But we're talking when you get to that, hey, this huge assembly. All of those tools, as great as they are, maybe it wasn't the best practices of when to use them or how often to use them.
And that's why you came and watched us here, so that we could give you a couple of pieces of advice. So let me use fillets as a pretty good example. So at the part level, fillets make the piece look really nice. That might be how it's actually produced, but a lot of those sharp edges aren't really hurting much, especially when you get at the GA level. When you do your design, you can put fillets at any point in time when you're modeling. But if you're really going to be smart or sharp with how to use that tool effectively, you're going to put all your fillets, hopefully, at the end. And the reason is that when you're doing a simplified configuration, you can actually just roll back or suppress those features at the end of your tree. So you always want to have your most complex features at the end. And that reduces the graphics triangles. It could be something of non-functional surfaces, all these kind of different things that you don't need at the assembly level. So when you have the ability to do these things, maybe just take a break and see whether or not you need to do that. I see a lot at the assembly level as well, with whether patterns, the different mechanical mates. Again, all we've been recommending is that you just make sure you use the appropriate one for the task.
Do we have time for me to add a little bit to that?
Sure.
Okay, cool. So I showed this last year, and as we were talking here, I'm like, really ring a bell. So things with like these fillets. So if you've ever used the delete feature, or delete body feature,
Right.
You can use that 1,000 times in your tree. So as you're designing,
Yeah.
you can say, "Ooh, I have all these surfaces and stuff. I want to delete it." Okay, and you add a feature, and then you're designing more, and you have extra bodies, extra surface bodies, whatever. Oh, use that. You can use it. That is a great tool, and you can use it that way, but it's not the best practice. What you can actually do is you can use it to clean everything up, and then you can keep bumping it down your feature tree, and at the end you have one feature that is deleting everything instead of 32 of that same feature deleting stuff. So great tool. Don't not use it, but use it in the right way.
Yeah, we're really thankful for your question. If you have any others, we'll be able to get back to you. But now I think it's time to kind of wrap up and tell them a little bit about what we have for them.
Oh, awesome.
I think we have maybe the PDF that has a summary, the one-pager, right, of all the different tips kind of combined into 4 main ones. We want to make sure that you have access to that, so you can download your copy today. The link should be below the YouTube live stream. But now we also have the fun part where we actually have some prizes to give away.
Best part of the show.
Best part of the show. Thank you everyone for joining us today. Why don't you go ahead?
Yeah, so we have two prizes here. It's 2 good ones. So I'm going to go with the second place winner.
Okay.
And this is going to be for actually a Creality Ender 3 3D printer, and it's the new one.
Okay.
And it has all the bells and whistles, and it is a hobbyist printer, a really good solid machine. And our winner for that is actually Derek Hudson from Cooper Lighting
Derek
Solutions.
Hudson. Woo! All right. Thank you so much, Derek. We really appreciate you joining us today. All right, so the next one, and this is the last one, the first place winner is the Wireless Space Mouse Pro. And that's going to Peter Lowen from Hydrodyne Technology Incorporated. Thank you so much, Peter, for joining us today.
Good job, Peter.
And congratulations. I'm envious of your prize there. That's pretty cool.
I want one.
Yeah.
I used to have one.
Yeah, me too.
But I'd like it again.
Back in the day.
Yep.
All right, well, I think that wraps up our presentation today. Thank you all for joining us. I hope you got some benefit out of our talk. But we would love to partner with you if you're experiencing large assembly performance issues.
Let us know.
Yeah, let us know. We'd love to dig in with you and partner with you for your success to make sure that you're getting the most out of SOLIDWORKS.
Absolutely.
Yeah. So thanks everybody, and good luck.